Hello, everybody. So I got some questions today, and in the process of answering those questions, I thought it would probably be good if I had some videos that provided an overview, a summary, whatever you want to call it, of arithmetic and geometric sequences. So here I'll talk about all the formulas that apply and show you an assortment of examples to go along with it. Probably do the video in two parts, but let's see how it goes as I go through it. Okay, so first of all, there are two topics: the arithmetic sequence and the geometric sequence. Okay, and on this page here, I wrote down the definition and the formulas that are involved. Okay, I'll do them in parts. First, I'll do the arithmetic sequence and talk about some examples, and then go to the geometric. So, to start with the definition, an arithmetic sequence is a sequence which is nothing but a list of numbers in order where any term is the previous term plus some fixed number. Okay? Now, all right, that's verbally what it is. If I could just describe it to you, the formula for that would look like this: term n is equal to term n minus 1, meaning the term that comes right before it, plus d. D is that fixed number that you add to every term to get the next term. D, this number that you add to any term to get the next term, is also called the common difference. Okay? All right, now from there, I just want to show you the examples and then decide which of these formulas to use to solve it. Okay? All right, so let's look at this first example. Suppose that we have an arithmetic sequence where A1, meaning the first term, is 16 and D is equal to 6. D is that number you add to every term to get the next term. Now, before I talk about the questions that we're going to answer, then I want to say that from this I could tell you what the sequence looks like. Okay, the first term is 16. All right, so it's 16, and then you add 6 to every term to get the next term. So that would make the next term 22, right? 16 plus 6. All right, and then I keep adding 6 to every term to get the next term. That makes the next term equal to 28. And then it goes on from there. You just add 6 every time. Okay, so you could keep writing that out if you wanted to. For whatever your purpose is, that's what it's going to be. Now, here's what I want. Can I find an, meaning the formula for the general term? So, in other words, is there a formula that will tell me what any term is? Here I just started writing them out. But, maybe like, could I jump right to the 75th term? If I kept writing this out, I would eventually get to the 75th term. That's what A75 means. But, I'd say I don't want to write the whole thing out to get there. Can I jump straight to it? That's what AN is going to do. Okay, so let's go back up here and look at the formulas. I've got this one. It says this will let us find any term. That sounds like what we need. And then I've got this one that says this will calculate the sum, or what you get if you add together the first n terms of the sequence. Well, between those two, this is definitely the one I want. It will let me find any term. That sounds like what I'm trying to do. Okay, so let's do part one like this. Part one is that AN is, now that formula that I just showed you up there is A1 plus n minus 1 times D. That's how you find any term of an arithmetic sequence. That's the formula that will let you jump straight to the 75th term if that's what you need to do. Okay, so in my case, AN is A1. Okay, the first term, that's 16. And N is the unknown. N is the variable. So we just leave that as N minus 1. Okay, and then D is what you add to every term to get the next term. In our case, that's equal to 6. Whoops. All right, so it's going to look like this. Now, that will do it. Like this formula right here will tell you what the 75th term is, if that's what you want. But as is normally the case in math, then we do some simplifying. If we can combine things, then we combine them, and so on. Okay, so I could simplify this by distributing that 6 And if I do that, I'll get an is equal to 16 plus 6n minus 6. Now I can combine some things at this point, and I'll get my final answer, which is, well, so what do I got? 16 minus 6, so that's 10 plus 6n. Okay, so there's my answer to part 1. This formula will allow me to find any term I want, the general term. I can jump straight to the 75th term without having to find all the numbers up to that point, okay? All right, so there's my answer to 1 right here in this box. Question 2 is, what's the 75th term? Well, that's exactly what this will allow me to find. Once again, without finding all the terms that lead up to that point, okay? So let's see, the 75th term would just be a matter of letting n be 75 in this formula right here. Okay, so that would be a sub 75, meaning the 75th term is 10 plus 6 times 75. Okay, all right, and that's going to be 460. All right, so the 75th term is 460, which I guess I could find that if I kept adding 6 and got the next term and the next term and the next term, I could eventually get to the 75th term, and it would be 460. But I didn't have to do it that way because that's what this formula allows me to do. All right, so let's see, first problem is done. Let's look at the next one. So this one says just to calculate. The way I would read this, if I was to read it to you, is the sum from 1 to 125 of 7 times I minus 4. Okay, so here's what that means in concept. Okay, I take I being 1, I start at that number 1, and I put it in this formula, and I count all the way up to 125. That's where I end, and I add all those results together. So it would look like this. If I put 1 in here, what's 7 times I is 1, okay? 7 times 1 minus 4, that would be 3, okay? And then I count my way up to 125. So next I go to 2. What would I get if I put 2 in? So 7 times 2 is 14 minus, so that's 10, all right? And then I'll keep going just to show you what this thing looks like. Then I go to 3. So 7 times 3 is 21 minus 4, so that's equal to 17. Okay? All right, and then it keeps going. And I'm not going to write out all the numbers because there's a lot of numbers. I have to like count my way up to 125. But I don't know, let's do this. I'll find the 125th term, and so 7 times 125, that one I don't know, minus 4, so that's going to be 871. Okay. All right. So anyway, so that's what it looks like. All right. Now, from there, I guess all it's asking for is what you get when you add all this together. Okay. All right. Sorry, pause my video because my computer seemed a little glitchy. But anyway, so I have written out what this means. And then my task is to find out what is 3 plus 10 plus 17 plus, all the way up to the very last number, what you get when you put 125 into this thing, which is 871, okay? Now, I could have written this whole thing out and added all those numbers together, and if I did that, I would have the answer. So I could do that, but, you know, I'm here to teach you certain things, and one of those things is how you apply these formulas. Now, first of all, I've got these formulas, but the formulas for the arithmetic sequence are different than the geometric. What kind of sequence is this? I guess I didn't talk about that. I just wrote this out, okay? So is this a sequence where it looks like that you find any number by the previous number plus some fixed number? So let's look at it. When you have 3 and then 10 and then 17 and so on, what kind of sequence is that? So we could do like this. If I take, the way it should work is that I'm adding the same fixed number to every term to get the next term. So it's like 10 plus this number d is equal to 17. or 3 plus this number d is equal to 10. So you could solve for that this way. You could say 3 plus this number d is equal to 10. D is equal to 10 minus 3 as a result. So d is 7. So it's 3 plus 7 to get 10, right? But if I keep adding 7, does that give me the next number? 10 plus 7 is 17. So this is arithmetic, okay? I didn't want to assume that. I wanted to show you how I would know. It is true that if you take any number and you add 7, you get the next number. And you could verify that all the way through here if you wanted to, okay? All right, so let's see. This is arithmetic, and I guess what I'm saying I want is the sum of the first 125 terms of it. Like, what's 3 plus 10 plus all the way up to 871? There are 125 terms in this sequence. Oops. Okay, because I started with I being 1, and that got me the first term, and I counted all the way up to 125. So I want the sum of these 125 terms. Is there a formula that would allow us to do that straight away? That would be this one, okay? It says if you have an arithmetic sequence and you want the sum of the first n number of terms of that sequence, and that is what we're looking for in this problem, okay? It says the sum of the first n terms is n over 2 plus a1, or times a1 plus an. Okay, so let's apply that, okay? So we're going to use this formula. S of 125 is found by Sn n over 2 a1 plus an. Okay, now we are looking for the sum of the first 125 terms. We could find that by letting n be 125 in this formula. So we'll get 125 over 2 times, and then a1 is the first term, and that's 3 plus an is, in this case, term 125, which is 871. All right? And so that will do it. Okay, now I can just calculate this and I'll have my answer at that point. But before I do that, I would feel better if I made sure that you're okay with my chain of reasoning. First, I wrote this out. Then I verified that it was arithmetic. That it is true that if you add 7, in this case, to every term, you get the next term. Then I told you that what this amounts to is finding the sum of the first 125 terms of an arithmetic sequence, okay? And then I identified the formula, and then here is what I get when I apply it. All right, so let's see what this is. 125 over 2, and then times 874, it turns out. And that turns out to be 54,625. Okay, so 54,625 is what you get if you take 3 plus 10 plus 17 plus all the way up to plus 871. Okay, all right, so we got that one. Let's look at the next one. So here it says we have an arithmetic sequence, okay? The fourth term is 81, and the fourth term is 41, and the ninth term is 81. And then the question is, with that, can you figure out what the seventh term is, okay? All right, now for this problem, I don't think that either of these formulas is directly applicable, okay? You at least can't use them in the form that you see them right here. So the way that we'll solve this one is by our understanding of how an arithmetic sequence works, okay? So let me show you. I've written out already what this sequence looks like, okay? I don't know the first term. A1 is the first term. I don't know the second and third terms either. That's what A2 and A3 are. I do know the fourth term. That's 41. I don't know the fifth, sixth, seventh, and eighth terms, but I know the ninth term is 81, okay? So fourth term's 41, ninth term is 81, and I don't know the rest of them. And I want the seventh term, all right? I want this one. So how am I going to do that? Well, think about how this sequence should work. We have to find a way to use what we know, all right, to figure out what we want. So the way that I think that we can use what we know is this, that in this sequence you would do what? You would add this number d to every term, and that would get you the next term. Okay? That is how it works. So I'm kind of mapping it out here. I'm saying that I take 41, I'd add d, I get the 5th term, I'd add d again, I get the 6th term. And look at what we see there. It looks like the way that you get from 41 to 81, from the 4th term to the 9th term, is you take 1, 2, 3, 4, 5 jumps. Okay? And jumps is not some precise mathematical terminology, but you see what I mean. So here's how I'll express it. If you take 41 and you add d 5 times, then you will get 81. That's how you get there, and that's how an arithmetic sequence works, right? I mean, that's the way it is. Now that will allow me to solve for d, but I want to highlight something real quick before I solve this and give you the answer. That 5 right there refers to my 5 jumps. You take 41 and you take 5 jumps of this number d, and you get 81. Okay? But I feel better if I write that down, so I'm going to write it down. So 5 jumps. That's what this significance is in that equation. All right, so let's solve that at this point. If I want to solve for d, that's the unknown in this equation. I'd subtract 41 from the other side. I get 40, right? And then I get 5d is 40. If I divide both sides by 5, I get d is equal to 8. All right, so that's how you make your jumps. It's by 8. All right? Okay, now let's do part 2 of this. D is just a means to an end. It's not what I was trying to find. The question asked me, what's the 7th term? What's A7? And now I just know that number d, which is how you jump from one term to the other. But I could use this and this principle up here to find the 7th term. Isn't it true, by the same thinking that I've already illustrated, that if you take the 7th term, which I don't know and I'm trying to find, and you make 2 jumps of d, then you'll get 81. You'll get the 9th term, right? So there I'm taking 2 jumps. Okay, yeah. Same idea, right? It's just I'm jumping from the 7th term to the 9th term. All right. So let's solve this one now. I want to solve for the 7th term, so let's see. I'm going to go ahead and put the fact that I know that d is 8, so 2 times 8, and then I get 81. And then I get the 7th term plus 16 equal to 81. Then I'll subtract 16 from both sides, and I'll get 81 minus 16, 63. Okay? Oh, sorry, 65. Alright, 65. So there's your 7th term. So that'll be my answer. Let me write my answer. I like to write my answer in a way that makes it look official. So let's see. 7th term. Alright, 7th term found to be 65. Alright. So that's how I would do a question like this, that's off the charts as far as formulas that we have that we normally use would not be applicable. If I understand what I'm dealing with, if I understand the way the sequence works, I can figure out some way to get the answer. Now, quick disclaimer, the way I've showed you to do this is not the only way to do it. If you were trying to solve this and you had no idea how, you might figure out some different way. That's the way math is. But this is a way that I think is good for me to show you because it appeals to your understanding of the previous questions. It's consistent with the way you think about those. And I think if I can do things in a way that's consistent across the problems, that will make it easier.